Hey, what's up, Ziguanas? This is day 29 of 30 days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language, Zig. My name is Dusan. Welcome to Zignited. Well, day 29 already. What if I stop here? Like the obsessive compulsive people will go nuts. Yeah, and I'm not going to do that, of course. Let's see, today on the menu, we have missed functions, miscellaneous functions. I just wanted to see what we can take from here, from this other part of the docs, where I had, when I did the panics, I did the research here for a specific function, full panic. But there are, of course, others. So I would like just to go quickly through all these things. Maybe not through all of them, but just see what they have here. Since I finished with the regular docs, I mean the main part, the basic part of the docs, that is over. So this is interesting. Let's see. So for types, okay, this is nice that they have listed them all here. I mean the basic ones, integer and others, but these built-in types, array hash map unmanaged, ArrayList. So yeah, some of these we already saw in the docs. ArrayList align unmanaged, ArrayList unmanaged, auto array hash map unmanaged, hash map unmanaged, exec bounded array, okay. Double linked list, so I guess then there are single here. Yeah, single linked list as well. Lib dynamic bit set unmanaged in number array, in a map, in a set. Yeah, the standard ones. Hash map unmanaged, MultiArrayList. Options. Priority dequeue, per queue, progress random, ring buffer, segmented list, semantic versions, single linked lists. Yeah, we mentioned that. Static bit set, static string map with EQL, string array hash map, target thread, trip, tz, and URI. These are some namespaces as well. Yeah, remember C. Testing, yes. Let's see fs, what is there, because I do intend to play with the next version of any line, so I want to play with files. Let's see what is here in file system. So they have types, AtomicFile, directory, and file. So let's go first here. It explains something. Okay, let's see first the fields. So file, then prepare to the buffer, destination base name, file open, file exists. This is to tell you if it's open, if it exists. Close the on the init. Okay. And directory. It says like if it's directory or not, probably. Or no, it says in which directory it is, I guess. Then values random bytes length. Okay. Functions. They have these three. So the init, finish, and init. Let's start with init, the other way around. So destination base name. Okay, to set it up. Hi Robert, how are you? See, this is constant slice of U8s, destination base name, then mode, file mode. So they don't store it here. So this is just when you initialize it relevant, I guess. Then they have directory, so this is stored already. Closed here on the init bool. And That's the one that exists, yes. Okay. And then the return type of init is this union, right? So it's initer and AtomicFile, or AtomicFile, let's say. AtomicFile. So AtomicFile is, this is the name, right, of this type. And this, the init function, is going to instantiate this. Okay. Note that their AtomicFile API may be more handy than this lower level function. Aha. So this is, I guess, here on the next one. Aha, okay, got it. That's why they call it AtomicFile. This is the, like they say, lower level function. So they probably wrap this up with there, and they have some easier automated with some preset things probably. Okay, so that let's just, because I'm here, I will just like read, it's not that long. So then the init, it's a pointer to itself. So atomic, oops, did not want to click. So it's pointer to itself, doesn't return anything. Always call the init even after successful finish. Then finish, again, receives the same thing. That's the pointer to AtomicFile. And it, this time it returns the union, so it can be void or finish error if there is an error. On Windows, this function introduces a period of time where some file system operations on the destination file will result in error. Aha. Access denied, including rename operations such as the one used in this function. Aha, aha. Okay, let's go to the next one. Next one is directory, dir. Oh, this is larger. Okay, only one field, FD. So this maybe stands for file descriptor or something like that. Handle. And then the types. Let's see, atomic file options, copy file options, entry, iterator, open the options, open options, prev status, status, symlink flags, walker, write file options. Then the values, handle, default mode and write file 2. And then bunch of functions. They're sorted alphabetically, so oh, there are so many of them. Okay, nice. Okay, let's start alphabetically because it's going to be quicker than to search for a specific thing which I even don't know. What is it here, like what exists. Let me just actually, before I do dir, let me just try file. I guess it's the same, if not, yeah, it's larger even. Okay, so let's go back to the dir. And let's start with the first function. So the access function. Let's see what first, before I read the signature, I just want to see what is it about. Test accessing subpath. Aha. Just to test accessing, not to actually access. On Windows, subpath should be encoded as WTF8 on VASI, WebAssembly. Subpath should be encoded as valid UTF-8. Yeah, I always hated like why Windows doesn't use by default the standard UTF-8, but yeah. On other platforms, subpath is an opaque sequence of bytes with no particular encoding. So it means on Linux and macOS both. Be careful of time of check. This is so weird because of these hyphens. Time off, check time off, use race conditions. Yeah, I remember when we were learning about race conditions, but I don't remember of this specific one. I forgot if we learned, I forgot what it is. It doesn't sound familiar, but I remember race conditions, yeah. When using this function, okay, so pay attention. For example, instead of testing if a file exists and then opening it, just open it and handle the error for file not found. Okay. So this is for this specific reason. When you do some specific things that can cause the race conditions. Okay. Let me see what you guys wrote. Robert says Zig standard is a bit too large to go through properly. Yeah. I mean, I've just seen like this small I want to say piece and bit in the same time. This small piece of these and like the dir and the file, and they're so huge. But yeah, I will go through dir and file just to see what's there in general because I want to use them. So these are the first functions that I want to use in the next coding session. So Robert continues, I personally prefer to browse through std declarations, and when you see something interesting, you can open the file with implementation simple in IDE. Yeah, that's true. Jorge, hello Jorge. Let's see, Jorge, what you say. Time of check, time of use means you check something. It then changes to some invalid state and you mess up. Thanks for explaining. That makes it a common cyber attack vulnerability. Aha, yeah. Okay. So maybe I will not focus on the signatures and outputs because I will forget anyways, but I just want to go through the descriptions to at least see what they do. So we went through the access, access W, same access, same as access, except asserts the target OS is Windows and the pet parameter is this. Okay, the Windows encoding different one, not the 8 one, null terminated, relative, or has the NT namespace prefix to do currently. Okay. Then XZ. That's hence like the W for Windows. Then XZ. Same as except the same as XS, except the path parameter is null terminated. AtomicFile directly access the .file field, and then call AtomicFile finish that we saw a few minutes ago to atomically replace destination path with contents. Always call AtomicFile deinit to clean up, regardless of whether AtomicFile finish succeeded. Destination path must remain valid until AtomicFile deinit is called. On Windows, destination path should be encoded as, of course, WTF8. On VASI, destination should be, again, UTF. On other platforms, I guess, same like before. Atomic symlink, same as symlink. So let's go first to symlink. Create a symbolic link, name symlink, path. Yeah, so I remember these. Symlink path, which contains the string target path, a symbolic link, also known as a soft link. Yeah, we played with this on Linux when we learned all these things. May point to existing file or to non-existing one. The latter case is known as a dangling link. If symlink path exists, it will not be overwritten on Windows. Both paths should be encoded again. So this is the same ending always. Then atomic is the same as symlink, except tries to create a symbolic link until it succeeds or encounters an error. Other than error, this one. Again, the same about encoding. Chmod. I like to call this chmod, change mode, right? Changes the mode, yeah, of the directory. The process must have correct privileges in order to do this successfully, or must have effective user ID matching the owner of the directory. Additionally, the directory must. So this is literally like the chmod instruction that you have in Bash. Right. Okay. Change owner, right? Change the owner and the group of the directory process must have. So the same. I mean, the same explanation like for this one. The restrictions. Close. Okay, self-explanatory. Closing the directory. Copy file. Guaranteed to be atomic on Linux. Okay, is merged and readily available. There is a possibility of power loss or application termination leaving temporary. Files present in the same directory as. Oh, this is like. There's a possibility of power loss or application termination leaving temporary files present in the same directory as destination path. On Windows, both paths should be okay. Same. Then create file, creates open source writes file with access, with write access. All file close. Okay. such that the path parameter has no null bytes. On Windows should be okay. Create file for Windows, right? That's just like different encoding of the path. Create file Z, null terminated, delete dir, returns error, dir not empty if, so this is not like the recursive, this is the regular one. If it's not empty, to delete recursively, C delete tree. On Windows, subpath should be encoded as double, okay. Delete dir Windows, delete directory, the same like, but Windows version again, delete dir Z, delete file, possibly the file it refers to. So delete a file name and possibly the file it refers to. Based on the open directory handle on Windows subpath should be encoded. Okay. Delete file Windows again. Delete file Z. Delete tree. Yeah, this is what they mentioned to recursively, right? Delete whether subpath describes symlink file or directory. The function removes it. If it cannot be removed because it is a non-empty directory, this function recursively removes its entries and then tries again. This operation is not atomic on most file systems. On Windows subpath, okay. Another thing, delete tree means stack size, like delete tree, but only keeps the iterator active at a time to minimize the function stack size. So it's not recursive. This is lower than delete tree, but uses less stack space. On Windows, subpath should be encoded. Okay. They always trick me, like I keep reading the end, which is the same always. Let's see the next one. Iterate. Okay, iterator. So I guess to go through the content of the file of the directory, no matter if it's directories or files. Iterate assume first iteration, like this one, but will not reset the directory cursor before the first iteration. So this one resets then before the first iteration. So this is going to continue then from the last position of the cursor. This should be only used in cases where it's known that the directory has not had its cursor modified yet. It was just opened. Okay. Make dir, create a single directory with relative or absolute path. Create multiple to make an path. C make path. Okay. To create multiple directories. Yeah. So operate on the absolute path. C make dir absolute. Okay. Make dir Windows. Make dir Z the same. Make open path. This function performs make path followed by open dir. So creates and opens. Supported by OS. If supported by the OS, this operation is atomic. It's not atomic on all operating systems. So Windows subpath. Okay. Again, they tricked. Make path. Okay. Calls make dir iteratively to make. So under hood it calls that one. Make entire path. Creating any parent directories that do not exist. Return success if path already exists and its directory. Not atomic. If returns error, the file system may have been modified regardless. Yeah, so it would just like do partially and then stop. When error metadata returns metadata struct representing the permissions on the directory. Okay. Open dir, opens a directory at the given path. Directory is a system resource that remains open until close is called on the result. The directory cannot be iterated unless the iterate option is set to true. So let me just go back quickly here. Yeah, it's not here. And was it in atomic file just to see? No. It's a different thing. Okay. Okay, directory server, blah blah. Can be iterated. Okay. Open directory Windows Z. Open file. Opens a file for reading or writing. without attempting to create a new file. To create a new file, see create file. All file close to release the resource asserts that the path parameter is an opaque sequence of bytes with no particular encoding. Wait, I jumped here. Search that parameter on Windows. Okay, this. Okay. Open file V, open file Windows, open file Z, read file, read all of file contents using a pre-allocated buffer. Return slice has the same pointer as buffer. If the length matches buffer.len, the situation is ambiguous. It could either mean that the entire file was read and it exactly fits the buffer, or it could mean the buffer was not big enough for the entire file. Okay. Read file alloc on success caller owns returned buffer. If the file is larger than max bytes, returns error, file too big. Read file alloc options on success caller owns. If the file is larger, error the same. If size hint is specified, the initial buffer size is calculated using that value. Otherwise, the effective size is used. Okay. Allow specific alignment and a sentinel value. A read link, read value of symbolic link, return value is a slice of a buffer from index 0. Asserts that the path parameter has no null bytes. Read link, okay, Windows and read link fuzzy. Fuzzy only same as read link except retargeted fuzzy, okay. And then Z. So I'm just like pause because this is the first time I've seen fuzzy instead of only Z and W. Real path returns the canonical absolute path name of path name relative to the directory, to this directory. If path name is absolute, ignores this directory handle and returns the canonicalized absolute path name or path name argument. Okay, Windows and also real path alloc. Okay, same as a real path, except caller must free the return memory. Real path, okay, Windows Z. Rename, change the name, location. This is also for moving. So rename, change the name or location of a file or directory. If new subpath already exists, it will be replaced. Renaming file over an existing directory or directory over an existing file will fail with error. File over a directory of file. Okay, existing, of course. With this error, not the okay. Okay, rename VZ. Set as CWD changes the current working directory to the open directory handle. So just like what is now current one, you then set the okay. This modifies global state and can have surprising effects in multi-threaded applications. Most applications, especially libraries, should not call this function as a general rule. Got it. So set as current working directory. Dangerous. However, it can have use cases in, for example, implementing a shell or child process execution. Not all targets support this. For example, VASI does not have a concept current working directory. Set permissions. The permissions according to the provided permission struct. This method is not available in VASI. Okay. Then the stat, probably the statistics. No, static, maybe static. No, statistics. Stat file returns metadata for a file inside the directory. Symlink creates a symbolic link named symlink path, which contains the string target path. A symbolic link, also known as a soft link, may point to an existing file or to a non-existing one. Latter case is known as dangling link, so this is the same like before what I explained. Symlink, okay. For these three versions, update file. Check the file size, m time, and I guess this is modification time, and mode of source path and destination path. If they are equal, does nothing. Otherwise, atomically copy source path to destination path. The destination file gains the m time, a time, and mode. So this is probably access time of the source file, so that the next call to update file will not need a copy. So saving time. Returns the previous status of the file before updating. If any of the directories do not exist for destination park, they are created. Then walk recursively iterates over directory, and write file writes content to the file system using the file creation flags provided. Okay, so I guess they are having these write file and similar functions that are targeting specifically files, because they take directory as parameter. So this is functions that are related to it, not only. Okay, and then let's see if I go back the file part. Let's see the other things here. Handle is handle, okay, the field, and values gid, handle inode mode, uid default mode. This is default mode given to POSIX operating systems for creating files. This is read write, 666, which is counterintuitive at first, since most people would expect like this. Yeah, this is like on Linux, it's like this. On Ubuntu at least. Okay, so I didn't know this about POSIX. Okay. Functions. Change mode. The same, so we don't have to go to the same ones. So change owner, close, copy range. Okay, this is new, but they don't explain, but we can guess what it does. Out file, offset. Okay. So copy from one file to another one with the specific offset and specific length. So I'm just curious if the offset, it's called out offset. Okay, now it makes sense. No ambiguity. Copy range all returns the number of bytes copied. If the number read is smaller than buffer len, it means the in file reached the end. Reaching the end is not an error condition. Downgrade lock assumes the file is already locked in exclusive mode, atomically modifies the lock to be in shared mode without releasing it. Get end position with async IO. Okay. Get or enable ANSI escape support, returns whether or not ANSI escape codes will be treated as such, and attempts to enable support for ANSI escape codes if necessary on Windows. Get position is cygwinpty. Don't know what this stands for. Yeah, I'm not sure what this stands for. Okay, let's go back here. Then is tty. Test whether the file refers to a terminal. See also. Okay. Lock. Locks when an incompatible lock is held by another process. Process may hold only one type of lock, shared or exclusive on a file. When a process terminates in any way, yeah, we learned about this when we learned about operating systems and deadlock and things like that. I remember, but I never did any coding with this. But I remember it was interesting. Metadata, mode, they don't explain much, so we will skip pre-AD. On Windows, this function currently does alter the file pointer. This PR stands for P stands for pointer read. right? Okay. P read all returns the number of bytes read. If the number read is smaller than buffer length, it means the file read. Yeah, this is same like before. P read V. The function on Windows currently does alter the file pointer. Okay, pointer read or P read V all returns the number of bytes read. So this is the similar like before. It's just V. P write on Windows currently, so they are explained in a very similar way. You write all, you write V all, read all, read to an alloc, reads all the bytes from the current position to the end of the file. On success, caller owns buffer. If the file is larger than max bytes, returns error. Okay. Then this one, read to end all alloc options. Yeah, this is a big one. Look at this. So reads all the bytes from the current position to the end of the file. On success, caller owns return buffer. If the files are, this is the same description like before. If size hint is specified the initial buffer size, calculate using that value. Yeah, the same explanation like before. Now this is just with options. Then reader, read V all. Same explanation again. Seek by repositions read write file offset relative to the current offset. Yeah, this is also a classic thing. Seek from end, but relative to end, the same thing. Seek to reposition read write offset relative to the beginning. Okay, so the current and beginning. Seekable stream, set and position, shrinks or expands the file. The file offset after this call is left unchanged. Okay. Set permissions according to the provided operation struct. Set permissions. This method is not available on Vazi. Yeah, because Vazi doesn't have its sandbox like JavaScript in browser. No, they say in Vazi, so I didn't know about the Vazi. I know the WebAssembly in browser is sandboxed, but yeah, it makes sense that they are sandboxing also Vazi on the local machine. Let's see. Stat, return stat containing basic information about the file. Use metadata to retrieve more detailed information. Operation time permissions and alike. Let's see what you guys wrote. Sorry. Robert says for reading, writing to files, there are reader-writer interfaces. You will use those most of the time. I'll check them out. Let me see. I'm very close to finishing this one, so I'll literally after I'll try to find them here in the docs. Where I was here, support ANSI escape codes, whether they will be treated as such without attempting to enable support for ANSI escape codes. Okay. Sync blocks until all pending file content and metadata modifications for the file have been synchronized with the underlying file system. Try a lock. Attempts to obtain a lock returning true. If lock is obtained, okay, this is related to the previous topic. So locks and false. If there was an existing copy of lock held, a process may hold only one type of lock. Yeah, they said this before. Unlock assumes the file is locked, so it will just unlock. Update times. Underlying file system may have different granularity than nanoseconds, and therefore this function cannot guarantee any precision will be stored. Further, the maximum value is limited by the system ABI. When a value is provided, then exceeds the range. The value is clamped to the maximum. Then we have write all. They don't explain them. Write file all unseekable. Does not try seeking in either of the file parameters. If writer write v, write v all. Let's see, we're going to function for stream. Okay, right? We all the I of x parameter is mutable because this one. This function needs to mutate the fields in order to handle partial writes from the underlying OS layer. The operating system layer expects pointer addresses to be inside the application's address space even if the length is 0. Okay, meanwhile in Zig, slices may have undefined pointer addresses when the length is 0. So this function modifies the base fields when the length is 0. Okay. Yeah, a lot of things, a lot of options. Let me see just one more time what you recommended. Reader-writer interfaces. How can I find them? So I'll try to search here. These are the built-in types where they are. So I'll try to search here. So let's say reader interface. I say the reader just. Let's see what you guys say. They're both returned from the file you were in, or just search for them. Let me go back here. Not here, sorry. Here. So let me search. Here. The function reader returns the reader. I guess this is the one. Let's open up and see. Okay, this is the source code. Click here. Okay. So 1, 2, 3 parameters. Context reader and read function. Let me just see here. Reader and its union with use size. Looking the wrong one, sorry. Yeah, maybe I clicked away. It doesn't matter. So context type, reader type, then reader read function, which takes the context and the buffer of U8s. So reader as a union with the use size as a return value returns the number of bytes read. It may be less than buffer length. Okay. If the number of bytes read is 0, it means end of stream, not a condition. Fields, so one field. So they just save this. Here, reader is just like in case this function related to the error. Okay. I mean, not point is the buffer, but also I want to say it will return possibly the error. Types skip bytes options. Let's see what that is. And they don't explain here. Self bytes, skip bytes options. Skip bytes, self, numbytes use 64, home time options. Okay. Then the values error functions. How many of them? Okay, not too many. So they are all inline. Yeah, inline functions. First one, any, returns any reader. The only parameter is constant pointer to self. Then inline, okay, they are all inline. Is bytes that has so either boolean or no and the file error is the return, but here the parameters are self slice, sorry, self instance and then slice. Okay, inline function read. So this one, yeah, like what they said, returns the size. take self and buffer. And this is not a constant buffer, so then it's just like reading to this one, into this one. Read all, very similar. Read all alloc. Yeah, this is so cool when I see the return type. Okay, read all array list, list aligned, read at list, read bound by read bounded bytes, read byte sign, read bytes no end of file. So this is how basically the regime how you're going to read it. I guess if you do this one, that it will create array list in memory when it reads it. So then I guess the structure inside of the file has to be specific. Maybe that Zig object notation that we mentioned yesterday or something similar. Then read at least, read byte sign. Yeah, we went through this. Read enum, read int. Okay, read into bounded bytes. Let's see what you guys wrote. Unfortunately, Robert says, unfortunately, the documentation for those functions is not the best. Well, that sounds like opportunity for someone to work on it. Nice. More fun. Read enum, read integer, read into bounded bytes, read, yeah, we went from, no, they're similar names. So this was read bytes, no end of file. This is read no end of file, so not bytes. Different one. So the encoding is different. Then read struct endian, read until delimiter, and the same with alloc. Read until delimiter array list, read until delimiter or end of file, read until delimiter or end of file alloc. How it's like growing. It's like a story. Once upon a time, then it grows and grows. Read var int, skip bytes, skip until delimiter or end of file. This is read. The same ending, and this is skip. Same ending stream until delimiter. Oh, cool. Streaming. And they just don't mention this doesn't work in VASI, WebAssembly in general, which is cool. Okay, this is read, so I guess the write is very similar, but it's about write. Go through here, so the same fields, if I'm not mistaken, context and write, I don't, write are same, but context is the same. And this function, a bit different, of course. Let me see what you wrote. Robert says, to be honest, the inner workings of them will change. The underlying logic these functions when the so it will change when the IO interface rewrite lands. It's almost certain at this point, so there is no point. But when, no idea. Yeah, that's when the language is young. I mean, it's a few years already, yeah, but just like the stage of it and compared with other languages, yeah, it's young, which is also an interesting like time to be using it when it's uncertain. You don't know how it's going to grow, if it's going to go to a college or not, and those kind of things. Yeah, so you recommend that I use this, right? So for an inline, when I want to save things to files, you recommend that I use these writers and readers that we just went through the reader, but I'm going to go through the writer now, right? And let's see how it looks like. And it's smaller. Look at it. So this one is not so big like the reader. They're all on inlines again. all functions. So we have any, we have print, we have write, write all, write byte, write byte n times. Ah, this is cool. So you can literally decide how many bytes to write. Write bytes n time. What is the difference? Aha, is the overloading or write bytes n times? Yeah, the name seems to be the same. It must be then overloading. Or I'm blind. I don't see the difference between in the name. Bytes n times. Because this somehow looks longer. Ah, bytes. Plural. Okay. Plural. Is there actually a function overloading in Zig? Can you do that actually? Let me see what Robert says. Yeah, maybe even BufferedWriter, depending on how much you spam the console. Okay, I'll definitely check this one as well. BufferedWriter. I will look for it. The no and yes, I guess, is for the overloading question, right? And I will just try to search as we speak here. Writer. Just open it here. You can't have two functions with the same name, okay? But you can do a lot with comp time. Yeah, I remember like the examples that we did so far when you basically generate different functions with different signatures with different types. So you have this generic type. This is what I was playing with a few days ago. At least that part I know how it works in comp time. Okay, let's see what else they have here. Write bytes n times, write bytes n times, write nt, write struct endian. Okay, and now let's see the buffered writer. So it has buffered size, which is usize, and the writer type, which is type, which can be determined. Okay, fields, unbuffered writer, writer type, and then buff. Wait, this was parameter. Okay, I thought these were fields. Okay. So these are fields. Unbuffered writer, which is of writer type, buffered size, U8 array, and then undefined is the default value. Then the usize, the end, is 0 by default. Then the types of writer, and then there is one error, and then they have functions, flush write and writer. And flush, of course, clears the buffer. Write should write, right? And writer, but this is write and this is writer, which returns the writer. I'm kind of like feeling funny saying like writer, like so weird. Let me see what you guys wrote. Hello, Jorge. I said hello. Sorry, I'm tired today. I already said hello to you. So Jorge says anything with function foo, comp time t type is effectively an overload. Yeah. So it's just like generated during the compilation time. So it's not that you manually do them, but the compiler will do that for you. Cool. Robert says, yeah, any type too. Yeah, this writer has only 3 functions inside. Pretty straightforward. So I guess it's easier to use this write than to buffered writer. And I guess there is a buffered reader as well. Let's try to find it. Yeah. And yeah, even simpler. Only read and reader. Buffered reader. Buffer size. Yeah, I definitely have to play with this, because for at this point, like, I don't understand why they would have field unbuffered reader type. So why do they need one more reader if they have the buffer and they have this reader type start size? Okay, this makes sense. This is easy. And the buffer, but why they would have here reader type and set to, I mean, this is what confused me, the name of the field, not the reader type. If I didn't read here it's unbuffered, I would guess it's buffered, but why they use unbuffered read? Let me see what Robert says. Buffered ones are somewhat obviously from the name buffering the input output, so it's more optimal for many calls to it. Yeah, buffered reader, buffered writer, and what else is there? Buffer. Oh, sorry for that. Oh, a lot of buffered things. Reader, writer, and AtomicFile. I'll just take a look this for out of curiosity. So I will not use it probably, because if they said the atomic option of non-buffered is not something that you should touch manually, but you should use the other functions, then I guess this one also is too low level to use directly, unless you have to do very specific thing. Okay. And let's see what else is buffered. Yeah, they're all actually sub parts of these, most of them at least. There is also HTTP protocol here, that is standard HTTP protocol mock buffered connection writer. Oh, so this is something that I will use probably for, I'm just curious, I want to see one thing, just like quickly ask ChatGPT. So let's say, and I have to bring it to this screen that you guys can see here. I just wrote Zig HTTP just to see what it will tell me quickly. So this is the same library, right? Let me drag it here, closer to where it was. Which one? Here, this one. So it will make it before this one. So it is std.http protocol. So std.http, yeah, this is the one they're explaining. Server. These are third party. Let me first go. Yeah, this is the third party. I want to see the standard one. The standard library includes built-in std.http module that provides the foundational tools for creating both HTTP clients and servers. Client allows for making HTTP requests to servers. It offers a straightforward API for common methods like get, post, etc., and provides control over headers, request bodies, and connection management. Developers have praised its ease of use, so I definitely have to try these. So this is something I mentioned, I think, when I was doing the second part of N in line. I mentioned that I want to do first the CLI. I'm looking at it here and like my mind, I'm too tired. So I wanted to do first the file, reading and writing, so that I save state of the game and read the state from the file. And then to do something with the WebAssembly, like the next stage. And then at the end, I mentioned that I would like also to do this. So not WebAssembly. So this still can be WebAssembly, not the point, but I want to say the first version of WebAssembly that I want to do is something maybe in the browser. But actually, maybe that's not the best idea, because then I will have to code JavaScript, and I don't want to mix them. Maybe it's better that I leave it as the last thing that I will do, so that I stick to pure Zig as long as possible for this project. And then once I do, so I have still a lot of things to do. I have to play with files first, then maybe do a HTTP client, but only Zig, like not in the browser. So on the machine running locally, a server and client that talk to each other. And maybe I will then adapt the game that I can play. Maybe like, I will probably do it synchronously. So I'm not going to do the async code yet. So I'm not ready for that yet in Zig. But maybe something like, I will assume that I will never try to play 2 times as X, or maybe I will just have something like a synchronous protection that you see if the turn number is stored in a file and that you read the file every time you play. There is a turn that you read it or something like that. I will think about it. So how I will synchronize without using async, but just to play. So the point is I want to play with these, not with the async. I want to play with the server and client, so that maybe like I run the server and a client, and I will simplify that you kind of like play against the server, not like 2 clients. Maybe then if I have time, I can also add a second client, and then that server actually literally serves, and then it's even easier for the states and everything. But the first version, what I had in mind is something like maybe a client and a server, and they play against each other. So let's say client is X, server is O, and they play against each other. Something like that, just to practice these things and to see how HTTP works in Zig. Yeah, this is interesting. Let me see what you guys wrote. I think the next message is Robert says buffered XXXX is just a wrapper around the reader writer to buffer it. So it holds the real one inside. Aha, this is the answer. Okay, thanks. So this is answering my question why you have where it is now. This is AtomicFile. Where is my writer or reader? Let's do it. This is generic writer. Okay, let's do the buffered writer, for example. So this one. So Robert is explaining why we have unbuffered writer, because this buffered is just a wrapper around it. Yeah, it makes sense. Okay, let's see what else Robert says next. There is a really basic HTTP client server in std, but there are better and more complex implementations in the ecosystem. So this is, I guess, what the AI suggests here. The ecosystem offers several popular third-party HTTP libraries. So they mentioned this HTTP-Z, developed by Carl Segin. Sorry if I mispronounced. Then ZEP. Then these are already like higher level frameworks. Oh, you already have. I didn't know that the ecosystem is so mature that you already have even frameworks for web. Because it's in my mind, because it's low level, I always thought that it's going to prioritize the system programming and that it's not close to actually do web in such organized way that you already have some frameworks. So let's see what they say. Higher level web frameworks beginning to merge, offering more batteries included solutions for web development in Zig. Yeah, this is so cool. JetZig and Tokamak. These frameworks are built on top of the performant HTTP Zig library. They aim to provide, they say like, they want to say it's kind of like their custom one. They aim to provide a more comprehensive set of tools for building web applications, including routing, middleware, and other features. Common frameworks from more established web ecosystems. These projects signal maturing landscape for web development in Zig, offering developers a path to build complex applications with greater ease. And this will be also so interesting for performance or some crucial things. You don't even need to do the entire project in Zig, but just like these key components that are sensitive to performance. In conclusion, while Zig STP module provides a solid starting point, I will use that one. Point for basic HTTP client and server needs. The community has produced powerful and performant third-party libraries like HTTP Zig. And this is, wait. Okay, this is just like the Okay, they call it HTTPZ, but the full name is HTTP Zig. Okay. Now it makes more sense. So they are building on top of that one. Okay, okay. Now it makes sense. Okay. Let me see what you guys wrote. Jorge wrote, are we looking at random cool functions? Yes, we are. So I started with the read-write functions because I mentioned before when I code the any line that the next thing that I would like to play with are these functions to read from file and write from files. That's why. Might I suggest MultiArrayList? Yes, sure. It's a huge, but scheming will show you how powerful Zig metaprogramming is. Look at the source though. Okay, let's take a look. Multi-array, Robert says multi-arrays list is kinda insane. Might not be the best place to start, but it's awesome code. So I guess I will take a look. I'm curious, but I guess at this level I will not understand a lot of it. And these performance-wise elements that are most interesting, I will probably miss a lot of them. And then Jorge says Carl Segin, or I don't know how to pronounce the name, is correct. He has Postgres, SQL metrics, WebSockets, and more. Nice, nice. So I will look for it now. Yeah, this was just like I was inspired by these HTTP here, and I just wanted to see not about these buffered wrappers that they have here, but just to see how the HTTP works. That's why what is there in Zig when it comes to HTTP. So that's why I wanted to just use AI. But yeah, so this is all about connections, and yeah, nice, nice. And let me now search for, can I copy here, or I will type MultiArrayList? Yeah, I can copy. So let's do this here. MultiArrayList. Yeah, huge one. Let's read through it at least. MultiArrayList stores a list of struct or tagged union type. It has to be tagged. So a multi-array list, that's the name. Instead of storing a single list of items, multi-array list stores separate lists for each field of the struct, or lists of tags and bare unions. So for each of the fields, you can have a different thing there. That's cool. This allows for memory savings in the struct if the struct or union has padding, and also improves cache usage if only some fields or just tags are needed for a computation. The primary API for accessing fields is the slice function. So we'll read that one, which computes the start pointers for the array of each field. Because each field is an array, right? So the slice will calculate the zero index basically of each of these. From slice, you can call items, dot items, and then dot field name to obtain a slice of field values. For unions, you can call dot items, dot tags, or dot items, dot data. Let's see parameters. It's type, fields has bytes, length, which is use size 0 by default, so no length by default, and capacity again by default 0. And the bytes, let's see what they say. They set it undefined. And what is it? So they call a line of t. So they take the type. They take the align of it. Then they use this align. So I will not even try to pronounce what this is, how they call it officially. But of U8, something like that. Types, field, and slice. So those are the supported types. Values empty. Then add 1, extends the list by 1 element, returning the newly reserved index with uninitialized data. Allocates more memory as necessary. Okay, so adds 1 and returns the index. add one assumed capacity, extends the list by one element, asserting self capacity is sufficient to hold an additional item, returns, it assumes, returns the newly reserved index with uninitialized data. So I guess this is faster. If you are sure there is something there, you can just call it and it doesn't have to check and save some processing time. Let me see what you guys wrote. Jorge says, look at array list at least. No, I've started already with this. Sorry, multi-array list that you recommended. Robert says, Jorge Manuel. He responds to Jorge. Is right. Robert says that Jorge is right, that the source itself is better to look at than the doc. Yeah, I forgot. Yeah, you mentioned source. Sorry. I completely forgot that you mentioned source. Let's see. Okay, so assert method, so they import a bunch of things. So debug meta mem std, and then what they say, multi-array stores a list of struct. So this I think the same what we read there. Oh no, it's a little bit different. Let's see. Multi-array list stores a list of struct or tagged union type. Instead of storing a single list of items, multi-array stores separate lists for each field of the struct or lists of tags and bare unions. This allows the memory savings if the struct or union has been. Yeah, it is the same. Okay. For a second, I thought I hadn't read something. Okay, let's see the function multi-array list, comp time t, and the same type is the return. And let's see, yeah. So this is when someone asks me like, which book are you reading now? I will say I am reading multi-ArrayList. Okay, let's see. Let's at least scratch the surface. Return struct. Okay, and then this is where the start begins. And because it's a return statement, I guess it's the very end where it finishes. Okay, now I'm into test, so I skipped over a bit. But okay, these are all tests. So okay, not so large. So here I guess it's the no. This is also test. Oh, it's a lot of testing here. Okay, so here it's where it ends. I don't see the line number. There aren't any, but yeah, it's not that bad. So it's like the third of this is a test list. So let's see. They return a struct, and then we have the first field bytes, which is again that weird type that I saw in the docs. So the same thing. So yeah, they are setting these things are the same like in docs, of course. And what is interesting is the rest. So the first next thing is this constant called empty of didn't want to click, sorry, of the self type. And I will zoom in a little bit that you can see now this code. So the type of itself, and again it has the same fields because the type. Then another one, they call it elem, and then they do switch. So I can guess this is a state machine. Okay, let's see. First they switch if there is a struct at the field. Then in that case the switch returns the value of t, and this becomes t. If it's union, then it will capture the u, and then it will make this struct, which is then, wait, the struct doesn't end here. Who knows where it ends? It's very hard to follow, but because of the alignment, I would say here. Maybe where, oh no, this is already different switch here, sorry. Wait, here, oh, maybe it's a nested switch, yeah. Yeah, this is a nested switch, sorry. Okay, so let's see. This one captures u, and then inside of this struct, there is this constant called bear. which they assign to the type of, and then there is a strike. It's very hard to follow the parentheses because I'm not in the IDE. I can copy paste this. Let me copy paste in the one that where it was playground, this one. Now let's see. Here I went too far. So this struct, where does it? Aha, here it ends. Okay, now it's easier to follow. Then, and I will zoom a little bit. This one here, struct ends here. Okay, now it's easier to follow. And this struct, then they set the field of union to another nested struct. So this one that I highlighted. So this is basically this one. This one, nested one, is with these 4 fields: layout, which is U layout, tag type null, fields is U fields, and the CLS is the address of the empty struct. Okay, then they have tag. Yeah, it's very hard to follow. They have the tag constant, which equals to U tag type or release comp sorry, compile error. MultiArrayList does not support untagged unions. So this is going to be true, otherwise it's not tagged. Then the tag here and the bear. The bear was the thing, yeah, that we got from here. Then from T, the outer type, they return this. What they do, they create a tag which is meta active tag outer. So they take the active tag of the outer, then they return. So they take that same tag, set it here as tags, and then the data is inner switch. They switch the tag, and then they want to see what if inline else. So inline if inline else. So if not, if false, right? They capture it as T, and then they have union init built-in function, which they, yeah, this is so nesting, like nesting things that are nesting in nested things. Okay, let's see from here. Tag name, they get it. Then they put that into the field built-in. Then they provide outer and the tag name here. And that is one parameter in the union init. The next one is tag name. And the third one is bear. Okay. Okay. Yeah, this is going to take a lot of time. I don't want to make because I'm already like 1 hour and 15 minutes into the stream. So I will pause here because it's really huge. This will take me like for I don't know how long, maybe 2 hours to read only this this one. Let me just go back here for a second just to see quickly if I can. Oh no, this is zoomed. So where it was multi-array. This is, I think I came from here. Yeah, just to see quickly what it has and what it does, because it's so huge. So add one assume capacity. That's why those I read. Append extends the list by 1 element, allocates more memory as necessary. Append assume capacity. Again, the same, but with assuming the capacity in bytes. So to get the size. Clear and free. Okay, so you pass the allocator because probably it's going to underhood deallocate. Void, so it doesn't return anything. Clear retaining capacity. Invalidates all element pointers. Okay. Clone, create a copy. So this is self-explanatory. Init release all allocate memory. Ensure total capacity. Modify the array so that it can hold at least new capacity items. Implement superlinear growth to achieve amortize O1, big O notation, append operations, invalidates element pointers if additional memory is needed. Ensure unused capacity, ensure unused capacity, modify the array so that it can hold at least additional count more items, invalidates pointers if additional memory is needed. Yet, obtain the data for one array element, insert, so I can guess what it does. Inserts item into order list, shifts all elements after, and including the specified index back by 1, and sets the given index to specified element, may reallocate and invalidate iterators. Insert assume capacity, so the same, but with assuming items. Get a slice of values for a specified field. You need multiple fields, consider calling slice instead. Ordered remove the specified item from the list, shifting items after it to preserve order. Remove and return, so pop, remove and return the last element. Yeah, this is pretty standard pop, like in Python. Or return null if list is empty. Invalidates pointers to fields of the removed item element. Resize, adjust the length to new length. Does not initialize add items if any. Set, override the one array element with new data. So only one. Set capacity, modify the array so that it can hold exactly new capacity items, invalidates pointers if additional memory is needed. New capacity must be greater or equal to len. Shrink and free, attempt to reduce allocated capacity to new length if new length is greater than 0. This may fail to reduce the capacity, but the data remains intact and the length is updated to new length. Okay, shrink retaining capacity, reduce length to new length, invalidates pointers to elements, to element items. New line keeps, so starting from new line, keeps capacity the same. Slice, compute pointers to the start of each field of the array. If you need access to access multiple fields, calling this may be more efficient than calling items multiple times. Yeah, they said that. Sort, function guarantees a stable sort. The relative order of equal elements is preserved during sorting. Read more about stable sorting. Okay. If this guarantee does not matter, sort unstable might be a faster alternative. A context has the following method. Okay, a function less than context, type of context, a index usize, b index usize, boolean. Okay, sort span sorts only the subsection. Cool. Of items between indices and a and b, excluding b. This function guarantees a stable sort. So again, sort span unstable, so the same but unstable. Sort unstable, the same like sort but unstable. This function does not guarantee a stable sort. Relative order of equal elements may change during sorting. Yeah, this may be faster than b. Okay. Swap remove. Remove the specified item from the list, swapping the last item in the list. This is not preserving order, but it's injecting the last one in its place. Okay, fast but does not retain list ordering. Yeah, it makes sense. When you reorder, you have to like copy multiple times depending on the size, and that's why it's slower. Yeah, this is very cool if you don't care about the position. Who owned slice? The caller owns the return memory, empties this multi-array list. Yeah, this is interesting. So this is not the first time I've read it. So I don't remember anything in the examples, but I remember reading it. Something like this, like a rule, but I haven't touched it. So still not sure how it works. Let me see what you guys wrote. Sorry. Where was I? Robert says type constructs a type at compile time. The more fancy and use safe way to do it, but you can truly modify the way it works then. Jorge says, yeah, maybe looking at it, this wasn't the best idea. No, it's very interesting, but because it's literally like the end of the stream, I just had to stop so that I don't make it like a 3-hour long video. That's the only reason. Robert says, for example, you can make an enum that when you switch on it, it won't require for you to exhaust all the cases, etc. Generally, don't use type unless you know what you're doing. Yeah. Robert says to Jorge, it might have been a small mistake. And then Jorge says, but the concept is cool. They take every single field in the struct and create a data structure. Sorry, I'm so tired. I slept 3 hours yesterday, previous night. So they take every single field in the struct and create a data structure that manages different arrays for each field. Which is great when iterating over one of two fields. Yeah. That's cool. That's cool. So I guess once I start playing with it, I will then have these whoa moments when compared to something else. And what Robert says, and for memory savings, cache is happy. Yeah. Cache. Yeah, so this is huge because when I opened the docs, I just saw these types, the list of them, there are like 30, 40 of them. And then I thought, okay, this is not so small number of types. But then when I clicked, when they started opening up, then I was like, okay, this is not small. This is very, very big. And then when I saw the source, so this would take, I don't know how much time. And it does make sense, of course, to go through the entire docs. I mean, this part of it, because it's so huge. So the first one made sense because it's more condensed. But this one, I guess it's going to be better if I just play with things, and then when I need something, I try to find it in the docs. So when for example, when I want to sort something, I will search for sort in the docs and see, aha, this is how you can sort, and play with those things. And but it is helpful, like the first where it was here. Yeah, so this part, you just see the built-in data structures. That's so cool. And there are a lot of them. So let me see. And do you have to import these like with std, or they're in the namespace out of the box, all these? So if I want to use one, can I just write, for example, which one? Static bit set, for example. Just write it down and it's there, or I have to import from std collections or whatever, something like that. And here namespaces. And this one has its own hash map. What's in crypto? Certificates, authentication, hash. Yeah, cool. What is this, fast Fourier, or what is this? Oh, this, yeah, this is not cryptographical. Fast Fourier is different. Fixed field arithmetic, okay. Yeah, fast Fourier is something different. It's a transformation. Awesome. Let's see what you guys wrote. Robert says std arrays list. For example. Okay, thanks. So they're all in the, so maybe not this one that has its own namespace, but the others are in the std. Thanks. Just to know where to start looking for from. just to see how long it source. Yeah, but there are a lot of tests as well, so it's not that big that you cannot make a video about it maybe, but at this point I just don't want to read. And a lot of tests, which is also cool to see how they test, things. Let me see what you guys wrote. Jorge says, you can const ArrayList equals import std. Aha. Yeah. Cool. The standard things that we do at the beginning. Like, yeah, this is how I mostly used it, so that I have a short identifier. That's cool. Yeah, so a lot more things than I thought there are in the docs, so I could make this not 30-day challenge, but like 1,000-day challenge and never finish it. So tomorrow, I don't know which functions I will cover, but I will definitely come back to here. Maybe I'll try like this MultiArrayList to see if I can do one video about it and to go through it, because it's interesting. And that would be then the last day 30 of this initial coding challenge. So like I mentioned before, I'm going to continue streaming things, but it's going to be a bit different. So I'm probably going to stream Zig links next, and maybe I will do on side some random lead code things in Zig. So I think Robert said that what did I say, LinkedIn? Lead code, I want to say, I don't know what I said. Lead code, I think Robert mentioned that lead code doesn't support Zig, so that you cannot test Zig there, but I will just like see what they expect as results. Of course, the tests are hidden. Some of them I think are at least hidden, but I will just like test the outputs that are there. So it might happen that I don't have actually the working code that answers completely the question, because I don't see the tests, but I will do my best to cover logically the most parts, at least those that are visible. That's an interesting thing. Maybe I will also do, yeah, but I think I will do what I said. So I was about to say advent of code, but this is also a bit longer journey. So this is like 25 days times 2 each day, and it will take me forever, and I'm not as fast with Zig like with some other languages still. Of course, I'm just starting, so these will take who knows how long if I start the advent of code with Zig. But yeah, I think Zig links are the next thing, the best choice. Then aside, when I have time, some special editions, like let's do this algorithm from lead code in Zig, something like that. And I will do what I said, so I will slowly edit videos for the tutorial, so that we have, I mean, you guys, I know you don't need them, but for the people who want to start learning Zig from scratch, so that I have something for them that is easing them into Zig. Let's see what you guys say. It would move under your fingers. STD involves kind of fast, actually. And then Jorge says, Zinglings will need you to the practice. You need to remember stuff. Yeah, that's cool. That's the goal, that I memorize these basic things and then maybe move on to something more complex. Then Robert says, Ziglings will be good to remember stuff up. Yeah. First ones will be fast. You already have some experience. Yeah. Hopefully, so that I don't get stuck in the first one, like 5 hours stream. The first one. So at the end, this end in line was in total maybe 4 hours. So I didn't expect it's going to take so long. Andre, what the Andre says, advent of code is pretty bad for Zig. It works best in bigger code bases, but this year I try to solve in Zig, optimizing each solution as fast as I can to learn SIMD and some other tricks. So you didn't like your advent of code experience with Zig? I did it only with Python with some of my students. So we went together through it. So just few days maybe from each year or something. Because they kind of quit after the few. They say, "Oh, like I cannot do this." So yeah, I never did it myself, like for myself. Yeah, truth be told, I had some crazy schedule before, like during the COVID. I worked literally not all days, of course, but some days, like weekends, I worked maybe like Saturday 15 hours, then Sunday 16 hours, and like that. So it was crazy, and I didn't have any time for myself to do whatever I want to do because of the work. But then later it got better. Robert says, Andre, were you able to do so about advent of code? Were you able to do it with built-in types, or have you resorted to inline assembly? And how did you go for it? And Andre says, no assembly. Interesting. Yeah, so built-in types were enough, but you didn't like the experience. Yeah, so if from what I remember, all the days started usually like you have this input as that you make as a file. So you get a file that you have to parse first, get the data from it, and then you do something. What is the task, the actual task? Yeah, I think I personally will not touch assembly in Zig at all. I might just maybe look at it just to see how it looks like, but I will not touch it. But I will use WebAssembly, so I will compile Zig, pure Zig, to WebAssembly. I will not code in assembly. That's the idea. And I found relatively recently, I found how it's called. It's kind of like a lit code, so it's teaching you to code many different languages. I forgot if I found Zig. How it was called, I will find it. Give me just a second. I can remember. No, I don't remember. Never mind. One more resource. Yeah, okay, so I think I will call it a day here. So like I said, I slept 3 hours in total yesterday. Code crafters. Yeah, one of them is crafters, and there is another one. It starts with E. It's something like it's a playful full word, like something like, you know, like if you say execute, but you say something like execute, something like that. So I forgot what was called. So level cover, not that one. It's on E. Give me a second, I'll try to find it. Exorcism. So let me see, but I'm not sure if I saw Zig there. So it was a while ago. But I mean, it's like, just like even if they don't have Zig, just like for inspiration, those kind of tasks that they have. So exorcism is the name. Let me see if they have Zig here. Yeah, they have. So this one. Yeah, you don't see. Sorry, I'm not sharing anymore. Back here. So this one. I never tried it. I've just like found it. I think I saw maybe some video on YouTube where someone was using it or something like that, and I thought, aha, this might be interesting, and then I just like clicked it and left it in my tabs so that I check it out, and I forgot. Like always. Well, I mean, look at my tabs now. So this started like the first day I had 3 of them, and I kept it at 3, maybe 2 for the first 10, 15 days, and then suddenly, like the last few days, yeah, prime factors, reverse string, darts. So Yeah, just like as an inspiration, maybe. But because they now even like support Zig, then doesn't have to be only inspirational. Look how many people are. This is interesting to see. So if you compare to, I don't know, for example, let's do something very popular. Let's do Python. Look like 500,000 of students, and then Zig 8,000, which is so cool that there are people. I mean that many people want to learn Zig. Let's see what you guys say. Robert says, never heard of this, might give it a try. Yeah, I never heard before. I literally by accident stumbled upon for fun. Yeah, always for fun. Let me see if they have Odin. No, Rust they have for sure. 120,000. Let's see. It's kind of, I'm also kind of interested to see these statistics and, well, not the statistics, it's just the number of people enrolled, but to compare this with the Stack Overflow survey. So it's approximately the same. In Stack Overflow, they say about 10%, if I remember correctly, developers there use Rust, and 1 point something, I think 1.3 Zig in a specific year. So it's kind of the same here. And let's see, Lua, they have it. Oh, it's 2 times more popular than Zig. This is also something like a surprise for me. I expected less. And let's see what else. That is not too exotic, but Elixir 47,000. Yeah. What you guys say? Andre says, I think the best feature of Exorcism is ability to ask community members. Aha, they have that. I didn't know. Improve your solution. That's cool. That's cool. But since challenge is pretty short, there is a limit to how much you can learn. Yeah. So yeah, I think they don't have, when I found about them, I think I just like did what I'm doing now, just like try different languages and see how many things are there. And I think that I've seen that they don't have that much for Zig like for other languages. You, for example, will never learn how to handle errors in Zig. And Robert says, Lua, probably because of games like Roblox. Yeah, you're right. So I forgot completely that they use it for Roblox. And let me see Julia, for example. Oh, so also not that small number. So I've heard this one is trying to, not trying to replace, but I want to say that people are trying to use this one for data science instead of Python. So I've never tried it. I don't know how it looks like, how it works, nothing about it. But I've just read about it. Julia for data scientists. I guess they have some list of languages, but I kind of like to do this here and see what they say. Let's see if they have a list here. Yeah, it's a lot of them. So R has to be already. No, it's not that the big. Yeah, I expected much more. For example, this is the first language that I expected much more R because data science. But I guess it's not that popular as Python for sure. Yeah, this is cool. Oh, this one, for example, I never heard of it. What is this? 271 students. Array-oriented and stack-based programming language that emphasizes concise point-free code that through tested programming. You never heard of it. You? Yeah, this is one of these esoteric languages. Okay. But it's cool that you can learn it here, that they are providing it here. And some time ago, like in 2019, I think, maybe 18, I stumbled upon Q#, like the Microsoft quantum programming language, but it's, of course, it's not still quantum. So they are like preparing the field so that you have some time to prepare when they actually create something that is really, this is more like quantum simulation. So they don't, of course, you don't have quantum computer to code, but they are using the quantum logic, let's say, so that you can practice this kind of thing. It's completely different. So I was also curious to see about the job listings for if so in 2019 I was searching like quantum software developer or something like that just to see what will show up, and I think I found only like 2 or 3 job posts in IBM. I think it was IBM, and they were looking for, when you see the experience, they were not searching at all for developers. So they were not saying like 20 years of development experience or anything like that. They were saying requirements, PhD in theoretical and experimental physics, because now this is the level like, I don't know, ENIAC in 1947. So you have to, like the mathematicians were the first coders back in those days, because they had to understand the logic of it and how to punch the cards and everything to make a machine do something. This is the level of quantum computing that we are. Okay, now it's like already a few years later, but it's still very, very early. And Microsoft has this like Q#. I did look on YouTube just to see how it looks like what is it about, and it's completely different concept. Like you don't learn, like the AND and OR logical circuits and these kind of things. That is the base for the classical computers. You learn completely like these superpositions and completely different concepts for it. Let me see what you guys wrote. Andre says, I want one for Ouya language. Yeah, that would be cool. Oh, wait, Ouya is there. No way. Yeah, it's there. Yeah. No, I thought you said like you want some like that we make a stream about you. Yeah, that's what I understood you. But yeah, it's here. It's on exorcism. Jorge then says, Love 2D is a popular love wrapper for SD. Aha. Balatro last year game of the year nominee was named. Aha. Yeah, I completely, I don't know, even I never heard of this game. Like I completely stopped playing games. So the last one that I finished was Assassin's Creed, and it was recently, like 2 years ago. I wanted to do like because I never played it back in the day, so I wanted to do it, the first one, Assassin's Creed. And since then I never played, maybe Heroes of Might and Magic a bit and nothing else. Then Andre says, solve previous advent of code in it. Probably my favorite language. Really? This is so cool. Yeah. Congrats for that. Yeah, definitely interesting website. Oh, this is the old one. I remember this. Oh, I never used it, but yeah, this is the old one. This is, I think, if I'm not mistaken, this is how it's called, the ERP software. My mind stopped. The most popular one, the most expensive one. Doesn't matter. Don't play ballot or you'll get addicted. Yeah. Yeah, luckily I don't have time at all to play, so I bought, how it's called. Oh my god, I have it on Steam. Give me just a second to see. Come on. I'm not logged in and I don't know my password even now. Doesn't matter. Like very dark game where you have how it was called. I don't even remember the name of the game that I played last. Doesn't matter. So just tried it, played it a little bit, and then I didn't have time. I had to work. So I hope one day I will. So then Andrew says how it's possible to have, I don't even know how to pronounce UIUA, but not APL. Probably because tooling for UIUA is much better. I guess the name is because of these characters they use to code. Yeah. Okay, guys, I will definitely go now. So this is already how many? 1 hour and 47 minutes long stream. Yeah, so I will stop here. And tomorrow, I still don't know if I'll travel. So if I travel, I will do one early in the morning European time stream. And then I will be on the plane in the afternoon. And I don't know when I will have access to a stable internet in the evening. So that's why if I travel, I will decide. I don't know. I have a plane ticket, but I don't know about the time. So I will see the tomorrow. If I travel, I'll do early 8:30. If not, then I'll be here approximately the same time like today. That's the idea. Okay, thanks guys. Like always, it was an interesting one. And see you next time. Have a nice evening, /day, /afternoon, / any period of day. And see you next time. Bye bye.